Hello there, and welcome to Sleepy Science Vault. Settle in. Take a slow breath. And let yourself get comfortable. Because we're about to talk about something extraordinary. Something that's happening to you right now. As you lie there. Perfectly still. You are moving. Right now. At this very moment. You are traveling through space. At an almost unimaginable speed. And yet, you feel nothing. Isn't that something? You and every other person on this planet are moving at the exact same speed. Not slightly similar. Not approximately the same. The very same speed. All of us. Together. And because we're all moving equally, none of us can feel it. It's a little like being on a perfectly smooth train. One that never slows down. Never speeds up. Never rattles or shakes. You were born into this motion. You came into the world already riding it. Already part of it. Before you ever took your first breath. Before you ever opened your eyes. You were already on the ride. And you always will be. The thing about movement is that we only ever notice it when something changes. When a car suddenly brakes. When a plane hits a pocket of turbulence. When an elevator lurches upward. Those are the moments our bodies sit up and say, something is happening. But when there is no change, when speed stays perfectly constant, the body simply settles and forgets it's moving at all. The Earth's rotation is like that. Beautifully, quietly, smooth. There is no bumping. No tilting from side to side. No vibration humming through the ground beneath you. Just a long, slow, effortless turn. Taking a full day to complete. So gentle. You could sleep right through it. And you have. Every night of your life. Deep inside your ears. There are tiny sensors. Remarkable little instruments. That exist for one purpose. To detect movement. And here's the fascinating thing. They're very good at their job. But they have a limit. Very small forces. Very gradual changes. Those slip right past them. Undetected. The rotation of the Earth is so slow. So enormous in scale. That those little sensors never register it. It simply falls below the threshold. Like a sound too low to hear. Like a color just beyond what the eye can see. There, but invisible to us. And then there's the question of reference. When you look out a window on a moving train, you know you're moving because the trees go by. The buildings slide past. There's something out there to compare yourself against. But the Earth has no such neighbor. Nothing close enough. Nothing fixed enough. To give our planet something to measure itself against. We float in the vast. Open. Quiet. Of space. And there is nothing nearby to say, look, you're spinning. So we don't see it. over thousands and thousands of years. Human beings grew up on this spinning world. And slowly, naturally, our bodies learned to call this motion stillness. The speed was woven into us, baked in, as you might say, to our deepest sense of what it means to be at rest. Stillness, for us, doesn't actually mean no movement. It means moving with the earth, perfectly, in sync. And perhaps the most beautiful thing of all is that the spin hides inside language itself. When we say we are still, when we say the ground is solid beneath us, when we say we are not going anywhere, we are describing a kind of truth that quietly contains a mystery. Because the stillness is real, and the motion is real, both at once, resting there together, like you are right now, still, and yet carried gently through the night. Close your eyes for a moment, or let them stay soft, unfocused, and just listen. Because what we're about to explore is happening right beneath you. Right beneath this very moment. There is a speed. A quiet, invisible speed. And it belongs to you. But here is something wonderful. Something that might surprise you. That speed is not the same for everyone. Where you are on this earth changes how fast you're moving. If you were standing at the equator right now, that broad, one band that circles the middle of our planet, you would be moving at roughly 1,000 miles an hour. Just standing there. Just breathing. 1,000 miles an hour. And yet, not a hair out of place. But if you were to travel north or south toward the poles, that great white quiet at the top and bottom of the world, your speed would gradually, gently decrease. Because the earth is a sphere, and a sphere is widest in the middle. So the middle has the furthest to travel in each full rotation, and it moves the fastest to keep up, while the poles, those still, frozen points, barely move at all, spinning slowly, like the very center of a turning wheel, almost perfectly still. It's a beautiful thing to imagine. All of us on this curved surface, each moving at our own quiet speed, depending on where we happen to be, and yet all completing the same full circle, together, in exactly the same amount of time. Now, you might have heard that the moon moves around the earth. And it does. Slowly. Magnificently. Taking about a month to complete its great loop. But here is something worth sitting with. The Earth's spin is actually faster than the moon's orbit. Our planet turns all the way around in just one day, while the moon takes weeks and weeks to make its patient journey around us. The Earth is the quick one, spinning eagerly, while the moon drifts in its long, unhurried arc. And then there's the sun, our great warm light in the sky. The Earth is moving around it too, not just spinning, but traveling, following a vast curved path that takes an entire year to complete, moving at nearly 67,000 miles per hour, around and around, year after year. Every year of your life, every year that has ever been lived on this world, the Earth has been making that journey, quietly, faithfully, carrying everything on it. Every sleeping person, every still lake, every mountain standing in the dark, all of it, traveling together. Now, you might wonder, with all this spinning and all this orbiting, shouldn't we feel something? Some kind of pull, or push, or gentle lean to one side? And the answer is yes. There are accelerations, forces acting on us, but they are so tiny, so vanishingly small compared to everything else, that they fade into the background, like a whisper in a quiet room. You could spend a whole lifetime never noticing them. Some of the other planets in our solar system spin much more slowly than Earth does. Venus, for example, takes longer to complete one rotation than it takes to travel all the way around the sun. Its day is longer than its year. Can you imagine that? A single day, longer than an entire year. Earth, by comparison, is quite the brisk spinner, moving with purpose, with a kind of gentle energy that has kept life ticking for billions of years. Now think about the sun and the path it traces across the sky each day, rising in the east, climbing slowly, reaching its peak, then descending, fading, setting in the west. That path, that familiar daily arc, is not the sun moving. It is us, the Earth turning, in the direction that we spin, sets the direction of that apparent journey. Because we rotate from west to east, the sun appears to move from east to west. A beautiful illusion, created by our motion, like watching the world slide past a train window, and thinking for a moment that the world is the one moving, and you are standing still. There are actually 2 lengths of day on Earth. Isn't that a gentle mystery? There is the solar day, the one we all know. 24 hours. The time from one sunrise to the next. The rhythm that sets our alarms and shapes our routines. But then there is the sidereal day, the true rotation of the Earth, measured not against the sun, but against the distant stars. And that day is ever so slightly shorter, about 4 minutes less. 23 hours, 56 minutes, and a few seconds, 4 quiet minutes, that the Earth earns back every single day, because of the way it curves around the sun, Just 4 minutes. But they add up. They accumulate. And they are the difference between two kinds of time. One we measure our lives by, and one the stars use. Deep beneath the surface of the earth, far below the ground you've ever touched, or ever could touch, there is liquid iron, moving, churning, following the slow pull of the Earth's rotation. And that movement, that deep, hot, invisible flow, generates something remarkable. It generates the magnetic field, the great invisible shield that surrounds our planet. That deflects the solar wind. That makes compasses point north. That lets migrating birds find their way home. All of it tied to the spin. The same spin you're resting inside right now, doing its quiet work, far below. And finally, there is something called angular momentum, a beautiful idea from physics. It simply means that a spinning object wants to keep spinning. It carries its rotation the way water carries its flow. Naturally, persistently. The Earth has enormous angular momentum, built up over billions of years. Since the very beginning. Since the cloud of dust and gas that slowly gathered, and slowly collapsed, and slowly began to turn. That first gentle turn has never stopped. It has slowed a little over time, very gradually, over vast stretches of years. But it has never stopped. And it is turning still. Right now. As you breathe. As you soften. As the weight of your body settles a little more into where you're resting, the Earth carries you in its long, slow spin, and has done so every moment of your life, every quiet night, every still morning. All that speed, all that momentum, all that invisible motion, holding you gently, steadily, as you drift. Let yourself sink a little deeper now. Whatever you're resting on, let it hold you completely, because that feeling, that gentle, certain feeling of being held, of not floating away, of being anchored to this world, that is what we're going to explore. Softly, quietly, together. Gravity. What a remarkable thing it is. You never have to think about it. You never have to remind yourself to stay on the ground. It simply holds you without asking anything in return. And here is something worth appreciating. As you lie there, perfectly still, gravity is vastly stronger than anything the Earth's spin could ever do. We talked about how the Earth is turning, how you are moving with it, at speeds that would seem impossible to believe. And that spin does create a tiny outward force, a very slight tendency to push things gently away from the center. You might have heard it called centrifugal force. That faint outward pull, like water wanting to slide off a spinning ball. But compared to gravity, it is almost nothing. Gravity is hundreds of times stronger, thousands of times more insistent. The spin barely even whispers against gravity's deep, quiet certainty. So you stay held, grounded, the way you always have been, the way you always will be. Now, when you step onto a scale, and it gives you a number, that number is not purely gravity alone. It is gravity, minus that tiny centrifugal effect from the spin. Your weight, in the most precise scientific sense, is shaped by both gravity pulling you down and the spin ever so gently, almost imperceptibly, pushing back. The spin is part of the definition of what weight even means. Isn't that a strange and lovely thought? Even something as familiar as your own weight contains a trace of the Earth's rotation inside it. A tiny signature of all that quiet speed. And because that centrifugal force is slightly stronger at the equator, where the spin is fastest, you would actually weigh just a small amount less if you were standing there at the wide warm middle of the world than you would at the poles. A few hundredths of a percent. Not enough to feel, not enough to notice, but enough for sensitive instruments to detect. A whisper of difference, written into the numbers by the turning of the Earth. Speaking of the equator, the Earth is not a perfect sphere, and this is connected to the spin as well. A perfectly still ball would be just that. A perfect ball. Round in every direction. But the Earth is spinning. And that spin, over billions of years, has gently pushed the middle outward, like a ball of soft clay, set to turning, and nudged ever so slightly into a wider shape at its waist. The Earth is what scientists call an oblate spheroid, which is a long and precise way of saying it is very slightly flattened at the top and bottom, and very slightly wider in the middle. The difference is small, just a little over 20 kilometers, on a planet nearly 13,000 kilometers across. You would never see it with your eyes, but it is there. A gentle bulge, a subtle roundness at the middle, the shape of a planet that has been spinning for a very long time. The oceans carry this effect too. Water is endlessly patient, endlessly responsive. It finds its level. It follows every force that pulls at it. And the centrifugal effect of the spin has very gently, over unimaginable spans of time, helped shape the surface of the seas, encouraging them to sit slightly higher at the equator, slightly lower toward the poles. Not dramatically, not in any way you would ever notice. Standing on a shoreline, watching the waves, but in the deep mathematics of the ocean, in the careful measurements of satellites, that slight influence is there. the sea shaped, in some tiny way, by the same rotation that is carrying you through the night. Now let's think about something we learned very early in life. The equator. The poles. North and south. These feel like solid, permanent facts about the world. And in a sense they are. But they are also defined by the spin. The equator is not a line that was there before the Earth started turning. It is the line that marks the place where the spin is widest, where the rotation reaches furthest out. The poles are the points where the axis, that imaginary line through the center of the Earth, emerges at the surface. The still points, around which everything else turns. Without the spin, there would be no equator. No poles. No north. No south. Just a sphere, equal in all directions, with nowhere to begin. And that axis, that imaginary line, is how we map the entire spin. We picture it running straight through the Earth, from the North Pole to the South Pole, like the axle of a wheel. And everything rotates around it, smoothly, slowly, once every day. It is one of those invisible lines that we draw in our minds to make sense of something real, like the lines of longitude and latitude that cross every ocean and continent. None of them painted on the ground, all of them perfectly meaningful. Here is something quietly fascinating. If you could hover above the North Pole and look down at the Earth spinning below you, you would see it turning counterclockwise, slowly, steadily. But if you then floated all the way around to hover above the South Pole instead, and looked up at the same spinning Earth, it would appear to turn clockwise. The same rotation, the same direction, but seen from opposite ends. It looks reversed, like a clock face, seen from the front, and then from behind. The spin itself hasn't changed. Only your viewpoint has. And somehow, that feels like a gentle reminder that many things in this world look different depending on where you're standing, without being any less true. And then there is the tilt. The Earth's axis is not perfectly upright. It doesn't stand straight, like a pole planted firmly in still ground. It leans about 23.5 degrees. A gentle, permanent lean, as the Earth travels around the Sun. And it is this tilt, combined with the rotation, that gives us the seasons. As the Earth moves through the year, different parts of our planet lean toward the Sun, and then lean away. When your part of the world leans closer, the days grow long. The sunlight comes at a steeper angle. The air grows warm. Summer arrives. Softly. Gradually. And when your part of the world leans away, the days shorten. The light arrives at a shallower angle. The cold settles in. Winter comes. And all of this, Every season you have ever felt. Every warm afternoon. Every cold gray morning. Every long summer evening. Every early winter dark is the result of that lean, working together with the spin. Two ancient motions combining to create the rhythm of the year, the rhythm that your body knows so deeply it can feel the seasons changing before the calendar says they should. So as you rest here now, held gently by gravity, shaped subtly by spin, tilted just enough to know the difference between summer and winter, between long days and short ones, between warmth and cold. Remember that all of this is simply the earth doing what it has always done, turning, leaning, holding, carrying you here in the quiet, in the dark, safe and completely still. Let your breathing slow now, just a little more. There's nowhere to be, nothing to do, just this, just the soft movement of air, in and out, and the quiet unfolding of something wonderful. Because we're going to talk about something you have experienced every single day of your life, without ever needing to think about it. The movement from light to dark and back again. That simple, ancient rhythm that the whole world breathes together is entirely the gift of the spin. Every morning that has ever greeted you, every evening that has ever settled over the day, every night that has ever brought you here, to this, to rest, all of it, created by the earth turning, one side facing the sun, bathed in light, warm and bright and busy, the other side turned gently away, held in the cool dark, quiet, still. And as the earth slowly rotates, the line between those two worlds, that soft boundary between day and night, moves across the surface, bringing morning to one place, while carrying evening to another. It moves constantly, gently. Right now, somewhere on this planet, the sun is just rising, spilling its first light across a landscape. And somewhere else, it is setting, painting the sky in colors, before letting the dark take over. All of it happening at once. All of it driven by the same quiet turn. Now, your body knows this rhythm more deeply than you might imagine. Inside you, there is a clock, a biological clock, woven into your cells, shaped over millions of years of living on a spinning planet. It knows when to feel awake, when to feel sleepy, when to release certain hormones, when to drop your temperature, when to begin the slow preparation for sleep. This internal clock runs on almost exactly a 24-hour cycle, because that is how long the Earth's day is. Your body and the Earth's rotation have been in conversation for longer than our species can remember. You are, in the most literal sense, a creature of the spin, tuned to it, shaped by it, dependent on it. And when you lie down at night and feel that familiar heaviness arrive, that gentle pull towards sleep, that is your body responding to the Earth, turning away from the sun, just as it always has, just as it always will. Time zones, those invisible lines that cross the map, dividing the world into hours, exist entirely because of the rotation. Think about it. If the Earth were not spinning, if one side always faced the sun, and one side always faced the dark, there would be no need for time zones. But because we spin, because morning arrives at different moments, for different parts of the world, we needed a way to organize that, to give everyone a noon. That actually means midday. A midnight that actually means the middle of the dark. And so the world was gently divided into slices, like a great slow orange. Each slice with its own time, each one a little ahead, or a little behind its neighbors, all of them adding up to one full rotation. 24 hours, 360 degrees. The spin made visible in the numbers on a clock. Have you ever watched a shadow move? It requires patience. You have to be still and quiet and watching. But if you stay with it long enough, a shadow will move. Slowly, deliberately, stretching and shifting, tilting across the ground. And that movement is the Earth turning beneath the sun, translated into shade. Every shadow on Earth is a kind of record of where the sun appears to be at that moment. And as the Earth spins, the shadows move in response, faithfully, predictably, like the hands of a very slow clock, which is exactly what they once were, before mechanical clocks, before digital displays, before the glowing numbers on your phone. People told the time by shadows. A stick in the ground, a stone pillar, an elegant carved sundial, all doing the same simple thing, letting the Earth's rotation write the time in shade, hour by hour, shadow by shadow. There is something ancient and lovely about the idea that time was once simply a shadow moving across the ground, driven by a planet turning beneath the sky. No batteries required, no signal needed, just the spin, and the light, and the shadow they made together. Now here is something gentle to consider. Because the Earth is a sphere, and because it spins, every part of it takes a turn, facing the sun. You're part of the world. Wherever you are right now is currently turned away, resting in the dark. But on the other side of the planet, The sun is shining. Someone is having their morning or their afternoon. And in a number of hours, your part of the world will turn back into the light, and your morning will come again. This has happened every single day of your life. The earth turning you toward the light, then gently away, then toward it again. A breath in, a breath out. Light, dark, light, over and over, for as long as you have been alive, and long before that too. The sunrise and sunset times, those change throughout the year, and you already know why. We talked about the tilt, that gentle lean of the Earth's axis, as the planet travels around the sun. The tilt and the spin work together, like two musicians playing the same slow song. In summer, when your part of the world leans toward the sun, the spin brings you into the light earlier and carries you out of it later. The days grow long, evenings stretch out, warm and golden, and in winter, when you lean away, the spin brings the light later and takes it earlier. The days shrink. The dark arrives before you're quite ready for it. All of this, the length of your days, the timing of your sunrises, the color of your evenings, written by the tilt and spin, working their quiet mathematics together. There are places on this planet, near the poles, where something extraordinary happens. In the height of summer, the sun does not set for days, sometimes weeks, sometimes months. It circles the sky, low and golden, but never quite dipping below the horizon. This is the midnight sun, and it is one of the most remarkable things the spin and tilt create together, because the pole is leaning so far toward the sun, and the earth is spinning on that tilted axis. The rotation simply never carries that part of the world into full darkness. It circles and circles, and the sun stays hovering, painting the landscape in a perpetual amber glow. For those who have never seen it, it is almost impossible to imagine a midnight that looks like a long, drowsy afternoon. And in winter, the same places experience the reverse. Weeks of near total darkness, the spin carrying them around and around, but never quite into the full light. Two extremes, created by the same two forces, tilt and spin. Now, think about the moment just before sunrise, or just after sunset. That soft, luminous time, when the sky glows, even though the sun is not yet visible, or has just slipped below the horizon. That glow, that beautiful, lingering light, is the atmosphere at work, bending and scattering the sunlight, reaching it around the curve of the earth, softening the transition between day and night. And the way that light looks, the colors it makes, the way it shifts and deepens, is shaped by the spin, by the angle at which the rotating Earth presents its atmosphere to the sunlight. The pinks and golds and deep blues of dawn and dusk are the spin's own colors, the palette it creates as it turns day into night, and night into day. And finally, there is noon, that moment when the sun is highest in the sky, directly overhead, or as close to it as it gets. True noon, solar noon, does not happen at the same time everywhere in a time zone. It moves slowly, following the spin, arriving first at the eastern edge, then drifting westward, minute by minute, as the Earth turns beneath the sun, at roughly 1 degree every 4 minutes. It is the spin made visible in the middle of the day, a slow wave of midday, rolling westward across the land, crossing deserts and mountains and oceans, touching each place in turn, before moving on. A noon that never stays, always moving, always following the rotation, around, and around, and around. So tonight, as you let the dark hold you, as your body clock winds gently down, as the shadows outside have long since merged into the full, soft dark of night, know that all of this, the rhythm of your tiredness, the timing of tomorrow's sunrise, the slow arrival of your morning, is the spin, doing what it has always done, quietly, faithfully, turning the world so that you can rest and wake and rest again. Just breathe and let it turn. Breathe in slowly and breathe out even slower. Let the weight of your body spread a little more into where you're resting, and imagine, if you can, looking down at the Earth from very far above, the whole round planet spread out beneath you, blue and white and turning, because from up there you would see something that you could never quite see from the ground. You would see the air moving, great sweeping rivers of wind, curving across the surface, spinning and swirling, bending in long graceful arcs, across continents and oceans. And all of that curving, all of that gentle bending of the wind, has a name and a cause. The name is the Coriolis effect, and the cause is the spin. Here is the idea. Settle gently. Imagine something moving in a straight line across the surface of a spinning sphere. As it travels, the ground beneath it is rotating, moving at different speeds, depending on how close it is to the equator. And so what looks like a straight path from above curves gradually, almost imperceptibly at first, but over long distances, the curve becomes clear. In the northern half of the world, things curve to the right. In the southern half, to the left. not because any force is pushing them sideways, but because the ground beneath is turning and changing the frame of reference. It is one of those effects that is invisible up close, but enormous when you step back far enough to see the whole picture. And weather, all the weather that has ever blown across this planet, is shaped by it. Every wind you have ever felt, every storm you have ever watched, every cloud formation drifting overhead, has been gently curved and guided by the turning of the earth. Think about the great wind belts, those broad rivers of moving air that encircle the planet at different latitudes. The trade winds that sailors relied on for centuries, blowing with such reliability, such faithful consistency, that entire civilizations built their trade routes around them. Those winds exist because of the spin. Warm air rises near the equator, moves toward the poles, cools, sinks, and flows back. But as it does, the Coriolis effect bends it, organizing that flow into distinct bands. Reliable, predictable, steady. The spin turning chaos into pattern, high above the weather, higher than the clouds you see from the ground. There are rivers of wind, moving at extraordinary speeds. These are the jet streams, fast-moving currents of air, flowing around the planet, from west to east. And they exist, in large part, because of the spin. The rotation of the Earth helps organize the temperature differences between the tropics and the poles. And those temperature differences drive the jet streams, pushing them along in their fast, winding paths. Pilots know them well. Flying eastward on a jet stream, you arrive faster, the wind carrying you like a leaf on a river. Flying westward against one, the journey takes longer. You are swimming upstream against a current made by a spinning planet. Now, think about hurricanes. Those great spiraling storms, seen from space. They are among the most beautiful and powerful things our atmosphere creates. And they spin. That spiral shape, that slow, magnificent turning of clouds and rain and wind, is the Coriolis effect. Made visible, made enormous. In the northern hemisphere, hurricanes spin counterclockwise, the air flowing inward and upward, curving to the right as it goes, creating that great left-handed spiral. In the southern hemisphere, cyclones spin the other way, clockwise, because the curve goes left there. Two mirrors of the same effect, on opposite sides of a spinning world, and both of them vast and powerful and inevitable. As long as the Earth keeps turning, the spin also helps maintain the great climate belts that stretch across the planet. Those broad bands of similar weather that make the tropics warm and wet, the deserts dry, the temperate zones mild, the poles cold and still. Without the spin, the atmosphere would behave very differently. Heat would spread, but without the organizing force of rotation, those clean distinct belts would blur, mix, lose their shape. The spin keeps them sorted, like layers settling in still water, each finding its place, each holding its character for thousands of miles. And because those belts are stable, the climates within them are stable too. The forests that grow in the tropics grow there because the spin keeps that region warm and rainy. Year after year, century after century, the tundra at the poles is tundra because the spin keeps those regions in their cold. The spin is not just moving the air, it is holding the world's climates in their places, letting life settle and adapt and flourish over enormous spans of time. There is another thing the spin does that is easy to overlook. It smooths out temperature extremes. Think about what it would be like if the Earth did not rotate. If one side always faced the sun, that side would grow unimaginably hot, baked by continuous sunlight, with no relief, no cooling night. The other side, turned permanently away, would grow bitterly, impossibly cold, dark and frozen, without end. But because the Earth turns, because every part of the surface gets its time in the light and its time in the dark, the heat is shared, spread around, distributed. No place bakes forever. No place freezes without end. The rotation is a kind of planetary fairness, making sure the warmth gets passed along to everyone in turn. And what is true of the air is true of the oceans as well. The great bodies of water that cover most of our planet do not sit still. They move in vast circular patterns called gyres, enormous loops of water turning slowly across entire ocean basins. The North Atlantic Gyre, the South Pacific Gyre, the Indian Ocean Gyre, all of them turning, all of them guided by the Coriolis effect, by the spin of the planet beneath them. These gyres carry warm water from the tropics toward the poles, and cold water from the poles back toward the tropics. They are the ocean's way of sharing warmth, moving heat around the planet, the way blood moves through a body, slowly, continuously, keeping everything in balance. The Gulf Stream, that famous river of warm water that flows up the eastern coast of North America and across to Europe, keeping winters in Britain and Ireland milder than they would otherwise be, is part of this system, guided and shaped by the spin and the coastlines, those edges where the sea meets the land, where waves break in foam and retreat. They inherit the spin too. The waves that roll toward shore are driven by winds that were themselves shaped by rotation. The currents that run along coastlines, the way water piles up on certain shores, the patterns of the tides, all of it touched by the turning of the earth. And speaking of tides, there is something beautiful to know. The moon's gravity pulls at the oceans, creating those great bulges of water that rise and fall twice each day. But those tidal bulges don't just sit still beneath the moon. They are dragged slowly by the spin. The earth rotates faster than the moon orbits, and so the tidal bulge gets pulled slightly ahead of the point directly beneath the moon, always running a little forward, being carried by the spin. And this interaction between the moon's pull and the earth's rotation is very slowly, over billions of years, transferring energy from the earth's spin to the moon's orbit. The earth's rotation is slowing by a tiny fraction of a second every century, and the moon is drifting just a little further away. Each year, a conversation between the earth and the moon, conducted in the language of gravity and spin, playing out over timescales almost too vast to hold in the mind. So as you rest here now, in the stillness of where you are, know that outside, the air is turning, the oceans are circling, the weather is being shaped by the same quiet spin that is carrying you through the night. All that movement, all that turning, out there in the dark and the deep, while in here, you are still, warm, and wonderfully at rest. Let the sound of imagined waves curl and break and pull back and breathe, and let the world keep turning without you needing to do a single thing. Let yourself settle even deeper now into the quiet, into the dark. There is nothing you need to hold on to, nothing you need to figure out. Just this, just the soft sound of these words drifting through the stillness. Because what we're going to explore now is something that surrounds you every single day, woven into the systems and rhythms that hold modern life together, and yet almost completely invisible. The spin, our old familiar companion, turns out to be quietly essential to almost everything we have built. Let's begin with time, that most familiar of things. You have known about time since you were very small. The hours of the day, the minutes ticking past, The seconds, each one a tiny, equal unit, measured and relied upon by every clock, in every room, in every corner of the world. But here is something worth holding gently. Those units, those hours and minutes and seconds, were not invented from nothing. They were not plucked from thin air. They are anchored deeply to the spin of the earth, the length of a day, that familiar 24-hour rhythm comes directly from how long it takes for the earth to complete one full rotation, and the hours and minutes are simply that rotation, divided and divided again into smaller and smaller pieces until we reach the second, that fundamental unit of time, the beat at the heart of every clock. Time is the spin made countable, and the length of a day isn't just a casual observation. It is a standard, a reference point that scientists and engineers and navigators have relied upon for centuries, for as long as humans have needed to agree on when things happen. The Earth's rotation has been the foundation, the unmoving anchor in a world of moving parts. Even our modern atomic clocks, those extraordinary instruments that can measure time to billionths of a second, are ultimately checked against the rotation of the Earth to make sure they stay in step with the world. It is a beautiful kind of partnership, the most precise human technology ever made, still looking up at the turning sky to make sure it hasn't drifted. Now, here is something that might surprise you. The Earth's rotation is not perfectly constant. We tend to think of it as steady, and in most ways that matter to daily life, it is. But if you measure it with atomic precision, you find that it varies ever so slightly. It speeds up a tiny amount. It slows down a tiny amount, influenced by things like the movement of the atmosphere, the shifting of ocean currents, even the slow redistribution of ice. As glaciers grow and melt, the planet adjusts its spin in the tiniest of ways, in response to everything happening on its surface. And because our atomic clocks are so precise, they occasionally get slightly ahead of the Earth's actual rotation. And when that happens, something quietly remarkable occurs. A leap second is added. A single extra second inserted into the official global time to bring our clocks back into alignment with the turning planet. The last second of a particular minute becomes 61 seconds long instead of 60, just for that one moment. And then time continues as normal. It has happened dozens of times since the practice began. A tiny adjustment made to keep human time honest to the Earth. It is one of the most quietly wonderful things that almost no one notices. A whole extra second given to the world because the planet asked for it. Now let's think about GPS. Those remarkable systems that can tell you exactly where you are on the surface of this spinning planet to within a few meters. GPS works by measuring the time it takes for signals to travel from satellites down to your device. And from those tiny differences in timing, it calculates your position. But here is the thing. Light travels at an extraordinary speed, and the Earth is spinning beneath the satellites. And the satellites themselves are moving through space at their own orbital speeds. If you didn't account for all of that motion, for the spin of the Earth, for the movement of the satellites, for the tiny effects of gravity on time, which Einstein predicted, and which are very real, the GPS system would drift, slowly at first, but accumulating, and within a day, your position would be off by kilometers. Every GPS device you have ever used, every map that has ever guided you, every delivery truck routed to your door, every aircraft guided safely to a runway, has been quietly correcting for the spin of the Earth and the strange, beautiful effects of relativity, without you ever needing to know. Human-built systems have in some ways outrun our perception entirely. We cannot feel the spin. We cannot sense the Coriolis effect with our bodies. We cannot perceive the tiny wobbles in the Earth's rotation. But the systems we have built are so precise, so sensitive, that they live in a world of detail, far beyond what any human sense can touch. They feel what we cannot. They correct for what we never notice. And they do it continuously, silently, every second of every day. It is a strange and humbling thought that the technology surrounding us is in some ways more attuned to the physics of the spinning Earth than the bodies we live in. And then there are the great computer models, the ones that simulate the climate, that try to understand how the atmosphere will behave, how temperatures will shift, how rainfall will change over years and decades and centuries. These models are among the most complex things human beings have ever built, running on enormous computers, crunching numbers day and night. And at the very foundation of every one of them, built into their deepest assumptions, is the spin. The Coriolis effect must be included, or the winds behave wrongly. The ocean currents must account for rotation, or they flow in the wrong directions. The day-night cycle must be precisely modeled, or the temperatures drift into nonsense. The spin is not just a detail. In these models, it is a baseline, a fundamental truth that everything else is built upon. Remove it, and the model falls apart. The climate stops making sense. Because the climate, the real climate of the real Earth, makes sense precisely because of the spin in those ocean gyres, those great turning circles of water that we talked about before. They have effects that reach into the everyday lives of ordinary people in ways that are easy to miss. The gyres carry nutrients upwelling from the deep to feed the surface waters, where fish gather in enormous numbers. The great fishing grounds of the world, off the coasts of Peru, in the North Atlantic, in the waters around Japan, exist where they exist, partly because of the gyres, partly because of the spin driving those currents that lift the deep cold water, rich with nutrients, up into the sunlit zone, where life blooms. The fishing industries that have fed communities for thousands of years, the trade routes that were built around reliable ocean currents, the entire maritime history of humanity has been quietly shaped by the turning of the earth and the currents it sets in motion. There is something deeply settling about realizing how much has been built on this one quiet fact. The earth turns, and everything follows. The length of our days, the ticking of our clocks, the satellites that guide us, the models that help us understand our world, the fish in the sea, the currents that carry ships, all of it resting on the spin, like everything resting on the ground, which is itself resting on nothing, but turning faithfully through the dark. So breathe out slowly and feel how much is held without effort, without struggle, without you needing to do anything at all. The systems are running, the clocks are ticking, the satellites are calculating, the gyres are turning, the leap seconds are being counted. All of it, quietly, perfectly, while you do the most important thing. You rest. You let go. You trust the spin to keep the world in order, while you drift gently into the deep, soft, forgiving, dark. Let your thoughts grow quieter now, like the last few ripples on the surface of a still pond, fading, fading, until the water is smooth and dark and perfectly still. Because what we're going to explore now has a kind of magic to it, a gentle mystery. The spin, our constant companion through all of these quiet hours, is in most circumstances completely invisible, not just to the body, not just to our senses, but even to many of the instruments and experiments that scientists use every day. Think about a simple experiment. taking place right now, in a school laboratory somewhere. A pendulum swinging, a ball rolling down a ramp, water flowing through a tube. In almost none of these experiments does the Earth's rotation make any detectable difference. The scale is too small, the time too short, the force is too tiny to leave any trace. The spin hides completely behind the everyday physics of small things, moving short distances over brief moments. You could spend years in a laboratory doing careful, precise experiments and never once find any evidence that the ground beneath you is turning. It is hidden that well, and yet it is always there. This is one of the most quietly remarkable things about the world we live in. A force that shapes weather, organizes oceans, defines time, and guides spacecraft, is also completely invisible to most human-scale observation. It only reveals itself when you go looking in exactly the right way. There is one famous experiment that does reveal the spin on a human scale. It involves a very long pendulum hung from a very high ceiling, left to swing for many hours. As the day passes, the pendulum seems to slowly rotate the plane of its swing, turning gradually, as if some invisible hand were gently redirecting it. But the pendulum itself is not turning. It is swinging in a straight line. It is the earth beneath it that is rotating, carrying the floor and the building and the observers around beneath the pendulum, while the pendulum, oblivious and patient, keeps swinging in the same direction relative to the stars. It is one of the most beautiful demonstrations in all of science. A single pendulum slowly tracing the turning of a planet in the quiet of a museum, or a cathedral, or a university hall. The spin, finally made visible, but it takes hours, and a very long pendulum, and a great deal of patience to see it, which tells you something about how well hidden it usually is. Only certain very precise instruments can detect the spin at smaller scales or shorter times. Gyroscopes, those spinning tops that resist changes in orientation, can feel the Earth's rotation as a faint drift in their direction. Ring laser gyroscopes, extraordinarily sensitive devices used in modern aircraft and submarines, measure rotation by comparing beams of light traveling in opposite directions around a closed loop, and they can detect the rotation of the Earth directly. A faint signal buried in very precise measurements. But there, unmistakably, the Earth's own turning, detected by beams of light, racing each other around a small loop of mirrors. It seems almost like a dream that something so vast should be readable in something so small. There's another beautiful consequence of living on a spinning, moving platform. When astronomers look at the stars, they are observing from a moving base. The Earth is spinning and orbiting the Sun, and the Sun itself is moving through the galaxy. All of that motion must be accounted for when making careful observations. The position of a star, as measured from Earth, shifts very slightly, depending on the time of day and the time of year, because the observer is standing on a spinning, orbiting platform and has moved between one measurement and the next. This is called aberration, the apparent shift in position of distant objects due to the motion of the observer. And it was one of the early pieces of evidence that the Earth was moving, not the stars. The sky itself contains the signature of the spin, written in the tiny shifts of distant points of light. Before GPS, before radio navigation, sailors crossed the world's oceans by looking at the stars, measuring their angles above the horizon, calculating their positions by the careful geometry of the sky. And the spin affected this too. The stars appear to move because the Earth turns. So a navigator needed to know not just where the stars were, but where they were at this exact time, on this exact date, in this exact year. The spin was woven into every calculation, into every page of the nautical almanac, into every careful angle, measured with a sextant, at sea, under stars, by someone trying to find their way home. And now, let us drift upward, away from the surface, into the realm of rockets and satellites, in the vast quiet of space, because the spin follows us there too. When a rocket is launched, it is not just fighting gravity. It is working with the spin. The Earth's rotation gives rockets a free gift, a head start, a boost, because the surface of the Earth is already moving at the equator at over 1,000 miles per hour, and a rocket sitting on the launch pad is already moving at that speed too. So when it launches eastward, in the same direction the Earth spins, it takes that speed with it into space for free, without burning a single extra drop of fuel. This is why launch sites are placed as close to the equator as possible, to capture as much of that free speed as they can. The Kennedy Space Center in Florida, Baikonur in Kazakhstan, Kourou in French Guiana. All of them positioned to take advantage of the gift the spinning Earth offers to anything trying to leave it. Some satellites take this even further. There is a special orbit called a geostationary orbit, where a satellite moves at exactly the right speed to stay above the same point on Earth all the time. It orbits once every 24 hours, matching the spin of the planet below. And from the ground, it appears to simply hover, fixed in the sky, unmoving. These are the satellites that carry television signals and weather data and communications around the world. They appear stationary because they have perfectly matched the pace of the spin, moving with the Earth in the same silent partnership that you have had with it your whole life. And because aircraft and missiles and rockets travel long distances over a spinning planet, flight paths must be carefully designed to account for the movement of the ground beneath. A rocket aimed at a target must be aimed at where that target will be when the rocket arrives, not where it is when it is launched, because by the time it gets there, the Earth will have turned and the target will have moved. This is the Coriolis effect again, showing up in the mathematics of every long-distance trajectory, every carefully planned flight path, every satellite launch, every interplanetary mission has the spin factored in precisely, mathematically, because if you ignore it even a little, you miss. The engineers who design these missions sit at their computers with their equations, and they subtract the spin. They peel it out of the measurements, account for it, correct for it, so that they can work in a frame of reference that is clean and still. And then, at the end, they add it back in to the final answer. They are so practiced at this that it becomes invisible. Just another step in a long calculation, but buried in every launch, every orbital correction, every satellite deployment is the quiet acknowledgement that the Earth is moving, and that the moving cannot be ignored. So as you drift here now, in your own perfectly still corner of this turning planet, know that above you, the satellites are orbiting, their paths precisely calculated, accounting for the spin. The rockets have been launched with it. The GPS has corrected for it. The pendulums in their tall, quiet buildings are tracing it. And the stars are shifting ever so slightly in their apparent positions as the Earth carries you and all its careful observers around and around and around. You don't need to do any of the calculating. or the correcting, or the accounting. Others have done all of that, so that your world works smoothly, quietly, without you needing to know anything at all about the spin, except perhaps this, that it is always there, beneath you, around you, carrying you through the dark, through the quiet, through the deep, restful night. Let the quiet deepen now, like the last light fading at the edge of a long, still evening. Colors softening, darkening, until everything is gentle and dim and restful. We have been talking about the spin in terms of science and satellites and precise calculations. But now, let us go somewhere older, somewhere slower. Let us go back, through time, through centuries, through millennia, to a world without electric light, without clocks on walls, without phones in pockets, a world where the sky was the only thing to look at. In the long dark hours of the night, imagine lying outside on a clear night, long ago, the ground cool and solid beneath you, the stars overhead, impossibly numerous, impossibly bright, because there is no other light to wash them out. Just you, and the dark, and the sky, and those ancient people, lying just as you are lying now, looked up at those stars, and watched them move, slowly, steadily, in long arcs across the sky, rising in the east, climbing, then descending, and setting in the west. And they reached the most natural conclusion, the conclusion that any careful observer would reach, without knowing what we now know. They concluded that the sky was moving, that the stars were traveling around a still and fixed earth, that the heavens were rotating while the ground stayed firm. And they were not wrong. Exactly. They were seeing something real, something true. The stars do appear to move. The sky does seem to rotate. They described accurately what they observed. They just had the cause the wrong way around. It was not the sky that was turning. It was the earth. But that understanding, that quietly revolutionary idea, took a very long time and a great deal of careful thought to arrive at. And in the meantime, those ancient observers did something extraordinary. They learned the pattern so well that they could predict it. They noticed that certain stars rose and set at the same time each year, that the sky repeated itself in a great slow cycle, that the heavens were a clock and a calendar all at once, and they built their lives around it, planting when certain stars appeared, harvesting when others rose, holding festivals when the sky told them it was time. Ancient calendars from every corner of the world, from Mesopotamia to Mexico, from Egypt to China, from the British Isles to the Pacific Islands, are all, in one way or another, records of the spin. They track the days, each one a rotation. They track the year, each one a full orbit. They divide time into units that are ultimately the Earth's own motions, translated into numbers, written in stone, or bark, or clay. These people didn't know about the spin in the way we understand it, but they knew its effects intimately, precisely. They lived by them, and they preserved them. For us, the sundial is one of the oldest human instruments anywhere in the world. A stick in the ground. That is all it needs to be. And the shadow it casts moves hour by hour, tracing the apparent path of the sun, which is the real path of the earth, turning beneath the sky. Ancient sundials have been found in Egypt, in Greece, in China, in gardens, in temples, in public squares, all of them doing the same quiet work, letting the spin write the time, in shadow and light, on stone or bronze or sand. There is something deeply soothing about the idea of the sundial. It requires nothing. No winding, no batteries, no maintenance. Just the sun, and the shadow, and the turning of the earth. It works today, exactly as it worked 3,000 years ago, because the spin has not changed. Now let us think about something more recent, something you may have seen. A long exposure photograph of the night sky, where the camera shutter is left open for hours, and the stars, instead of appearing as points, appear as long graceful curves, arcs of light, sweeping across the photograph, each star drawing a circle around the still point of the pole. These are called star trails, and they are among the most beautiful photographs anyone can take. With patience and a clear dark sky, those trails are the spin, made visible, made beautiful. Each arc is the earth turning, carrying the camera, while the star stays fixed. And the longer the exposure, the longer the trail, the more of the rotation captured in light on a single frame. If you left the camera open for a full night, the stars would draw almost complete circles around the pole. A whole night of turning, written in light on a single image. The pole star itself, Polaris, sits almost exactly above the North Pole, almost exactly on the axis of rotation. And in star trail photographs, it barely moves at all. A tiny circle, almost a dot, while all the other stars sweep around it in great glowing arcs. It is the stillest point in a turning sky, and ancient navigators found it with their eyes and steered by it for thousands of years, before compasses, before charts, before any instrument more sophisticated than patience. In a clear night, Polaris was home. It told you which way was north, and north told you everything else. Those sailors, crossing vast dark oceans, guided only by a star that stayed almost still, because it happened to sit above the spinning axis of the Earth. Were navigating by the spin, without ever knowing that was what they were doing. The spin was their guide, even then. Now, here is something gentle and lovely. When astronomers map the sky, when they give coordinates to stars, saying where each one sits in the great spherical map of the heavens, they use a system that is defined by the spin, the celestial equator. That great circle dividing the sky into north and south is simply the Earth's equator, projected outward into space. The celestial poles, north and south, are the Earth's poles, extended to infinity. The entire coordinate system that astronomers use to point their telescopes and share their observations and build their maps is the spin, stretched across the whole sky, like a reflection in a vast dark mirror. And the light from stars, as it reaches us, is very slightly affected by the spin as well, because the Earth is moving. As a star's light arrives, the motion shifts the apparent position of the star ever so slightly. This is aberration again. That gentle distortion, caused by an observer in motion, watching light from a fixed source, like standing in falling rain and tilting your umbrella forward because you are walking into it. The rain falls straight, but from your moving perspective, it seems to come at you from slightly ahead. Starlight is the same, arriving straight, but seeming to come from a direction ever so slightly shifted by the motion of the spinning Earth, carrying you through the night. And then there are eclipses, those extraordinary moments when the sun and moon and Earth align perfectly, and the moon's shadow falls upon the Earth. The path of a solar eclipse, the narrow strip of totality, where the sky goes dark in the middle of the day, moves across the surface of the Earth, partly because of the moon's movement, and partly because the Earth is spinning beneath it. The shadow races across the surface, faster than the spin alone would carry you. If you wanted to chase a total eclipse, to stay in the shadow as long as possible, you would need to fly westward, fast enough to keep pace with the darkness, running over the turning earth. People have done this, chased totality across oceans and continents, in supersonic aircraft, staying in the shadow for extraordinary amounts of time, all because of the interaction between the moon's passage and the Earth's spin. Two motions combining to create a shadow that races across the world. So as you rest here now, in your own small patch of darkness, think of all those ancient people who lay just as you were lying, and watched the stars move overhead, who built their calendars around the patterns they saw, who planted and harvested by the turning sky, who put a stick in the ground and let the shadow tell them the time, who found Polaris and steered by it across dark and unknown waters. They were all living in relationship with the spin, just as you are, even now, even here, even in this quiet, dark room. The stars outside, if you could see them, are moving overhead in their slow arcs, drawing their trails across the dark. And you, warm and still and held, are part of the same turning that those ancient eyes watched in wonder long, long ago. Let that thought carry you down into the soft and dreamless deep. Soften everything now. Your face, your shoulders, your hands. Let them be heavy. Let them rest. Because we're going to go somewhere very far away in time, back to the very beginning of things, and then forward again, all the way to now, on a long, slow, quiet journey. But first, let's stay here for a moment in the world of maps and mathematics and the strange shapes that a spinning sphere makes. When you try to draw it flat, you have seen a world map many times. Perhaps you have one somewhere in your mind right now. The familiar shapes of the continents, the blue of the oceans, the lines of latitude and longitude, crossing everything like a net laid gently over the world. But here is something worth sitting with. Every flat map of the earth is a kind of lie. A beautiful, necessary, carefully constructed lie. Because the earth is a sphere, and a sphere cannot be unrolled into a flat surface without tearing or stretching or compressing. Something, somewhere, and the way those distortions fall depends on the spin, because the spin defines the poles and the equator and the lines of latitude and longitude. And those lines are the skeleton that every map is built upon. When you look at a standard world map, and Greenland appears almost as large as Africa, even though Africa is 14 times bigger. That distortion is a consequence of trying to flatten a spinning sphere's coordinate system onto a flat page. The spin created the coordinates, and the coordinates created the distortion. And the distortion is simply the price of making the round world fit on a flat surface. There is no perfect solution. Every map trades one kind of accuracy for another, shape for size, direction for proportion, and all of it traced back to the spin. Scientists and engineers who work with the spinning Earth use something called a rotating reference frame, which is simply a mathematical way of doing calculations, as if you were spinning with the Earth, rather than watching it from outside. When you work in a rotating frame, the Coriolis effect appears as a real force, something that pushes things sideways, rather than as an illusion created by the rotation of the ground beneath. Both descriptions are correct, depending on where you stand, inside the spin or outside it. Mathematics flexible enough to hold both views at once. It is one of the things that makes physics so quietly beautiful. The same reality, described two different ways, both perfectly true, neither one more real than the other. In the Foucault pendulum, which we touched on before, deserves a moment more, because it is one of the most elegant things in all of science. A long wire, a heavy weight, and time. That is all it needs. Léon Foucault, a French physicist, sat one swinging in Paris in 1851, in the Pantheon, that grand domed building in the heart of the city, with a pendulum 67 meters long and a heavy iron ball, and he let it swing. And over the hours, the plane of its swinging slowly rotated, turning through the full circle in just over 32 hours. At that latitude, and the crowd that gathered watched in silence as a pendulum revealed the turning of the world. Foucault himself said that you could see the Earth rotating simply by watching the pendulum drift, the floor turning beneath the patient swing of a heavy weight on a long wire. It is still one of the most moving demonstrations in science, because it requires no instruments, no calculations, no expertise, just patience and a willingness to watch. And the Earth will show you its own turning in the drift of a pendulum over the quiet hours. Now, let us go deeper into time. Much deeper. The moon, our quiet companion in the sky, is slowly, very slowly, pulling on the earth through its gravity. And that pull is creating a kind of friction in the oceans as the tidal bulges are dragged by the spin and pulled back by the moon. This friction, this gentle resistance, is acting like a brake on the Earth's rotation, slowing it by a tiny amount each century, about 1.4 milliseconds per day, per century, which sounds like nothing, and in a human lifetime, it is nothing. You would never notice. But over millions of years, those milliseconds add up. They accumulate. And the Earth's day has been getting longer for as long as the moon has been orbiting us. Which means that long ago, the days were shorter, much shorter. 4.5 billion years ago, when the Earth was new, a day may have been only 6 hours long. The Earth spinning more than 3 times faster than it does today. Can you imagine that? For sunrises, in what we would call a single day, the young Earth spinning eagerly in the first light of the early solar system. And we know this not just from mathematics, but from fossils, which is perhaps the most wonderful part of this story. Certain ancient corals and other creatures grow in layers, day by day, season by season, like tree rings, but finer, more precise. And by counting those layers in fossils hundreds of millions of years old, scientists have calculated how many days were in a year back then. And because the year, the time it takes to orbit the sun, has stayed roughly constant, more days in a year means shorter days. Ancient coral fossils from 400 million years ago suggest there were around 400 days in a year back then. 400 days of approximately 22 hours each, written in stone in the growth rings of creatures that never knew they were keeping records of the spinning Earth. Isn't that extraordinary? The history of the spin, preserved in fossils, waiting for millions of years for someone to come along and read it. Now, here is something that brings us all the way back to the present. The Earth's rotation varies slightly, even now. Not just the long, slow slowing driven by the moon, but short-term wobbles, small speed-ups, tiny slowdowns, caused by seasonal changes in the atmosphere, shifts in ocean currents, the movement of groundwater, even the melting of glaciers. All of these things change the distribution of mass on and in the earth, and like a spinning skater, drawing in their arms or extending them, the Earth's rotation responds, speeds up a little, slows down a little, and in recent years, scientists have recorded some of the shortest days since precise measurements began. Days that were fractions of a millisecond shorter than the standard. So brief a difference that you could not perceive it in any way. And yet, the instruments measured it. The Earth spinning ever so slightly faster than expected, for reasons scientists are still investigating, still debating, still turning over in their careful minds. The Earth, even now, still surprising us, still hiding small mysteries in its spin. And in the midst of all this, all these changing days, all these slowing centuries, all these fossil records, and precise measurements, there is something that has not changed. Something steady. Something constant. The spin is there, as it has always been there, slowing imperceptibly over billions of years, but turning, always turning, through every ice age, through every mass extinction, through every civilization that has ever risen and fallen on its surface, through every night that has ever passed in quiet, through every person who has ever lain down and closed their eyes and let the dark hold them. The Earth has been turning, just like this, just like now, and will be turning still, long after the last clock has been wound down and the last map has been folded away. So let that be the last thought before you go deeper. The spin is ancient and patient and faithful. It was here before you, and it will be here long after. And right now, in this moment, it is carrying you as it has always carried you, without effort, without asking, through the long, dark, quiet of the night. Breathe out and let yourself go. Let your body become heavy now, beautifully heavy, the way it gets in the last quiet moments before sleep truly comes, when the thoughts slow down and the weight settles and everything softens into the dark. We are near the end of our journey through the spin, and this last part is perhaps the most wonderful, because we are going to discover that the spin is not just something that happens around life. It is something that may have shaped life itself from the very beginning. But first, something extraordinary. Something that connects the ground beneath you to the turning of the whole planet. Earthquakes. Those great releases of energy deep in the earth, when they are large enough, can actually change the spin. When a massive earthquake occurs, the rock shifts. Great slabs of the Earth's crust, moving suddenly, redistributing mass. And when mass shifts on a spinning object, the spin changes. Like that skater again, drawing in their arms, or letting them out. The 2004 earthquake in the Indian Ocean, one of the largest ever recorded, shortened the Earth's day by about 3 microseconds. 3/millionths of a second. Gone. The planet spinning ever so slightly faster because of the way the rock moved beneath the sea. And the 2011 earthquake in Japan did something similar, shortening the day by another tiny fraction. The Earth adjusting its spin in response to its own interior, moving. And it is not just earthquakes. When large dams are built, vast quantities of water that would otherwise flow freely down rivers to the sea are held back, gathered together in one place, high above sea level. And that concentration of mass changes the spin by the tiniest of amounts. The Three Gorges Dam in China, the largest dam in the world, holds so much water that scientists calculated it increased the length of a day by about 0.06 microseconds. A number so small, it means almost nothing to any human experience. But it is real, measurable, written into the spin by human hands. And then there is something even more remarkable: the melting of glaciers and ice sheets, as vast quantities of ice that have been sitting near the poles for thousands of years melt and flow into the oceans. The mass of the Earth is being redistributed, moving from high latitudes down to the sea, spreading outward. And this redistribution is not just changing the spin, it is very gently tilting the Earth's axis. Scientists have found that the movement of water from melting ice to the oceans is causing the North Pole to drift, moving the axis by small amounts. Each year, the Earth's very orientation in space, nudged by the movement of water on its surface, by the slow melting of ancient ice. It is one of the most profound things to sit with quietly, that human activity can tilt the axis of the Earth, not dramatically, not in any way you could see or feel, but measurably, detectably real. The axis that defines the poles, and the equator, and the seasons, and the coordinate system of every map and telescope. Gently, imperceptibly moving. The earth itself has a wobble, a slow, gentle sway in its rotation, called the Chandler wobble. The geographic North Pole does not sit perfectly still. It traces a small irregular circle over the course of about 14 months, moving by a few meters around its average position. This wobble is caused by the uneven distribution of mass in the earth, the movements of the oceans, and the atmosphere, pushing and pulling on a spinning, slightly imperfect sphere. And you feel none of it, not the tiniest hint of that slow, circular sway of the pole, describing its patient little circle. Year after year, it is imperceptible, completely hidden, as so much of a spin always is. And now, let us go even deeper into time and into life itself. There is a theory held by some scientists that the long, slow slowing of the Earth's rotation over billions of years may have shaped the evolution of life in profound ways. When the Earth was young and spinning fast, the days were short and the nights were short. The cycle of light and dark came and went many times in what we would call a day. And life in those ancient oceans was simple, microscopic, single-celled. As the earth slowed and the days grew longer, the periods of light and the periods of dark extended. And some scientists believe that longer days gave certain organisms more time to photosynthesize, to gather energy from the sun, and that this may have helped more complex life to develop, may have given evolution the time it needed to build something more than a single cell. The spin, slowing down over billions of years, may have been one of the quiet conditions that made complex life possible, that made you possible. We don't know this for certain. Science holds this gently as a hypothesis, a possibility, but it is a beautiful one, that the rhythm of our days, our 24-hour cycle, was not always what it is, and that the gradual lengthening of those days over unimaginable spans of time may have been part of what allowed life to grow more complex, more varied, more wonderful, all the way to here, all the way to now, all the way to you. The rotation of the earth creates the day-night cycle. And life on this planet has been shaped by that cycle so deeply that it is woven into living things. At the most fundamental level, we talked about the biological clock, circadian rhythms, that internal timing your cells carry. But it goes further than that. Plants open their flowers at specific times of day, tracking the light. Animals time their hunting, their sleeping, their mating, around the rhythm of the turning world. Trees grow differently in the long days of summer than in the short days of winter. Even the timing of crops, the planting and harvesting, that has fed human civilizations for 10,000 years, follows the spin, because it follows the seasons. And the seasons follow the tilt. And the tilt only means anything because the earth is spinning. The birds that migrate across continents and oceans navigate partly by the stars. Those same star patterns that move because of the spin. They read the sky the way ancient sailors read it, finding direction in the turning, finding their way home, guided by the rotation of the planet they were born on. The salmon that find their way back to the exact stream where they hatched. The butterflies that travel thousands of miles to a forest they have never seen. The whales that move through the dark deep ocean, following invisible paths. All of them responding to cues that the spinning earth creates. Temperature gradients, day length, star positions, ocean currents, all of them shaped by the spin. Life on Earth does not just live on a spinning planet. It lives because of one. It is timed by the spin, navigated by the spin, fed by the spin, guided home by the spin. And we are not special in this. In the grandest sense, every planet in our solar system spins. Mercury turns slowly, taking almost 59 Earth days for one rotation. Venus spins in the opposite direction, very slowly, so that the sun rises in the west and sets in the east. Mars spins almost like Earth does, with a day just 37 minutes longer. Jupiter turns, the fastest of all the large planets, a day of only 10 hours. Its great storm systems, shaped by a spin, far quicker than our own. Saturn, Uranus, Neptune, all of them turning in their own time, in their own direction. Spin is not peculiar to Earth. It is how planets are. It is a natural consequence of how solar systems form. From great rotating clouds of gas and dust that collapse inward, conserving their rotation as they go. Every planet a child of a spinning cloud, carrying its inherited turn. Through the years, through the ages, through the dark. But here, on this particular planet, the spin found something remarkable. It found life. Life that could be timed by it, and shaped by it, and guided by it. Life that could look up at the stars moving overhead, and wonder, and measure, and understand, and finally, lie down in the dark, and rest, in the knowledge that the turning will continue, without any help from them. So here you are, at the end of a long journey, through the spin. You have traveled from the invisible speed, beneath your feet, through the gravity that holds you, through the weather it creates, through the tides it shapes, through the satellites it guides, through the ancient fossils, that record it's slowing, through the earthquakes that briefly change it, all the way here, to this thought, that the spin is not just the background of your life. It is part of the reason your life is possible at all. And tonight, as you let go, as the thoughts become slower and softer and further apart, the earth is turning faithfully as it has turned every night of every life that has ever been lived on its surface, carrying you through the dark, gently, without effort, without end. You don't need to do anything. You don't need to hold on. You don't need to stay awake. The spin has you. The spin has always had you. From the very first moment you arrived on this world, and it will carry you through this night and every night that follows. Just breathe and let it turn. Let it turn. Let it turn.